This is the divisibility test for 4 that we teach to our students. An integer is divisible by 4 if and only if the number formed by its last 2 digits is divisible by 4. That means no matter what would be the forms of the other digits, as long as the last 2 digits or the number formed by its last 2 digits is divisible by 4, automatically the entire integer n is divisible by 4 as well. So we are going to verify this divisibility test using the idea of congruences. Please try to review the first video that we have shared for this playlist because it includes the necessary preliminary background concepts that we're also going to use here in order for you to understand this proof well. So let's start. Okay, let's have here our proof. But first, let us try to come up with n, be an integer with respect to base 10. We oftentimes use base 10 in proving or showing this divisibility test under congruence because it's easier for us to get the remainder, as we also talk about congruence, right? So if we have this n here, we can represent this in this form. Our first digit, no matter what the first digit is, times 10 to the power of m. Then, plus, you have here a m minus 1 times 10 to the power of m minus 1. Plus, you will have here, let's make it general, plus dot 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 plus a sub 2 times 10 squared plus a sub 1 times 10 to the power of 1 in your a sub 0, which is your units digit or the last digit, times 10 to the power of 0 is just equal to 1. This 2 would comprise the identity of our divisibility test, the last 2 digits. We are going to show that these last 2 digits is when divisible by 4, then the entire integer is also divisible by 4. We're going to show it later. Let's call it equation A, and we'll be going back to it later. Now, since we have established here base 10, okay, it's easier for us to get the remainder. Using base 10, you have 10 is congruent to 2 modulo 4. Why modulo 4? Because we're testing for divisibility test of 4. In the previous video, when we test the divisibility test for 2, we used modulo 2. When we also tried to test the divisibility test for 3, we have modulo 3. So right now, we're going to have modulo 4 because this is on the divisibility test for 4. In the next video, divisibility test for 5, then modulo 5, and so on and so forth. By the way, if you forget, this means that 2 here, the result there, is the remainder. Okay, that's very clear to say when 10 is divided by 4. Okay, so this is how it came to be. Our 2 here is the remainder when 10 is divided by 4 because we will have 8 and of course the remainder is 2. Okay, using this, we can now draw ideas on the remainders if we are going to have exponents for our 10 here. So by power law, this is a power law of congruence or the power rule. If we have 10 squared, we also, this is congruent rather to squaring as well the remainder. Okay, modulo 4. Because by power law for congruence, if you have your number here raised to an exponent, you will just get the remainder raised to the same exponent if you have the original form here. Take note, this is 10 squared is congruent to 2 squared is 4 modulo 4. But 4 modulo 4 is divisible, right? We can divide that. This is further equivalent to 10 squared is just congruent to 0 modulo 4. Because if you're going to look at 10 squared, that's 100. And 100 is divisible by 4. Right? That's why the remainder is 0. Okay? Next is 10 cube. Now, 10 cube, you will have here 2 cube here, right? 2 cube. Or you will have your 8, right? You will have here modulo 4. This means it's 10 cube is congruent to 8. Sorry, that's 8 modulo 4 because that's 2 cube. And 8 again is divisible by 4. So 10 cube is also 0 modulo 4. So these are the important concepts for remainders. Now if we're going to move further, if you have 10 to the power of 4, this is just equal to, I'm just using equal, okay? This is 10 squared times 10 squared, right? And since 10 squared and times 10 squared has the remainder of 0, this would be congruent to 0 modulo 4 as well. And all other exponents which are are even in remainder, okay? All, which also includes all even exponents. You have 10 to the power of 6, that's 10 squared times 10 squared times 10 squared, so 0 times 0 times 0, 0. If you have your add 10 to the power of 5, this is equal to, again, I'm using equality, 10 cubed times 10 squared, right? But the remainder for 10 cubed is 0. The remainder of 10 squared is 0. So this is just congruent to still 0 modulo 4 and all add exponents. Okay. So this is a generalization using power law. Let's coin this relationship B. Okay. Before we proceed, take note that you were able to understand this. Okay. You will have this original form. That 10 is congruent to 2 modulo 4. And then when you're going to have exponents, 10 squared, 10 cubed, you will have here 0, 0. And the rest would be a combination of both. Because you will have your 10 squared is 4. That's 4 modulo 4 is 0. And 8, then it will become 0 as well. Okay. So, we have that. Going back to A, which is our representation of n, okay, with base 10. And we are using here base 10. That's the concept. So you will have here our n is equal to a to the power of m, a sub m rather, 10 to the power of m plus a sub m minus 1, 10 to the power of m minus 1 plus dot 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 plus a sub 2, 10 squared plus a sub 1 times 10 plus a sub 0 times 10 to the power of 0, of course. Now, using or with modulo 4 in this expression, your n will no longer use equality but will be using congruent, okay, to this entire expression, a sub m 10 to the power of m plus a sub m minus 1 times 10 to the power of m minus 1 plus dot 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 plus a sub 2 times 10 squared plus a sub 1 times 10 plus a sub 0. Then you have here modulo 4. Okay? Again, we are verifying the divisibility test for 4, hence modulo 4. And this is where the connection of our A and B earlier will come in. Once you distribute your modulo 4, you will have a sub m times 10 to the power of m modulo 4. No other references will not use parentheses for modulo 4. I'm just placing it like that. Plus a sub m minus 1 times 10 to the power of m minus 1 modulo 4 plus dot 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 plus a sub 2 times 10 squared modulo 4 plus a sub 1 times 10 modulo 4. That's modulo 4 plus a sub 0 modulo 4. And once we distribute all of this, we can see this form here and here and here and here. And what are these? Using B. Look at our relationships B that we have gathered earlier. 10 squared is just 0 modulo 4. The remainder is 0. 10 cubed will also use 0. Our 10 to the power 4 is also 0. 10 to the power 5 is also 0, including all even exponents and all odd exponents. We will have 0 modulo 4. This would mean this n here is just equivalent to a sub m times 0. You have your 0. This is just 0. This is also 0 plus a m minus 1 times 0 plus dot 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 plus a sub 2. This is also 0 plus but I would like to add some changes. Let's leave this in the meantime. Leave this. Just for this the meantime, because our goal here is divisibility test for 4, which includes the last 2 digits. So let's just simply write it a sub m 10 modulo 4 plus a sub 0, and you have here modulo 4. So we did not apply it here yet. Okay, just bear with me. This would mean n is congruent to, that's 0, 0, 0. So you have here a sub 1 times 10 modulo 4 and plus a sub 0 modulo 4. Once we factor out modulo 4, you will have this form. A sub 1 times 10 plus a sub 0, and you will have here modulo 4. What is this now? What is this expression? This is actually the sum of, or I mean, yeah, aside from it being the sum, this comprises the last 2 digits. These are the last 2 digits. Going back earlier here on our A, here. These are the last 2 digits. So what do we mean by this? When can we say, when is, let's say this is C. When is C divisible by 4? That is, if we have this established here, modulo 4. If and only if, okay, that last 2 digit, a sub 1 times 10 plus a sub 0, that last 2 digit is congruent to 0 modulo 4. Sorry, that's modulo 4. Because if this is congruent to 0 modulo 4, you can substitute 0 here. So n 0, 0 modulo 4 modulo 4. And again, what is this? The last 2 digits. So when can we say that any integer is divisible by 4? Meaning any integer has remainder of 0 when divided by 4? With this shows that for an integer n be divisible by 4. What is this again? Okay, we can say the sum of, not the sum, not necessarily the sum, because yeah, automatically that's a sum, but we're talking about it, the expression as a digit or as a number. The last 2 digits. By the way, it's not sum, right? Because you have your 10 here. If this is without 10, say for example, then you can say sum of the last 2 digits. But this is with 10. That means we're taking it as digits. The last 2 digits form, or the number, sorry, I have forgotten the term. This shows that for integer n be divisible by 4, the number formed by the last 2 digits is also divisible by 4. And this is actually what we're trying to show, what we're trying to verify. Going back to the statement that we usually give to our students, an integer is divisible by 4 if and only if the number formed by the last 2 digits, this here, is also divisible by 4 as guaranteed by this proof. So we're able to do that by first having integer n with a base 10, and we have this ideas for remainders on modulo 4 using base 10. So we have this analysis here. You may want to review this part. And then going back to our A together with the B, we come up with this form, which is actually the last 2 digits, and that is only true. Our n is only divisible by 4, meaning this is 0, if our form here is also congruent to 0 modulo 4. This is the proof for the divisibility test for 4 using congruence. Thank you very much for watching.